Homework 1, problem 7. The problem states, and I quote, "The height of a hill in feet is given by the following equation, where x and y are the distance in miles, north and east respectively." I transpose north and east. That gives us a really weird coordinate system, right? Where if this is north, it corresponds to x, and if this is east, it will correspond to y, but hey, we'll live with that. Going forward, it asks further questions of where is the top of the hill. That translates to where is the maximum. How high is the hill? Translate what is the value at the maximum. And how steep is the slope at a point 1 mile east, 1 mile north? Or what is the slope at the point p I hat plus I j hat? So I'm going to go ahead and start this. To do this, I need to actually take the gradient of this thing, and the gradient of h is equal to the partial derivative of h with respect to x I hat plus the partial derivative of h with respect to y j hat. In order to do this, I have to actually take these partial derivatives. So the partial derivative of h with respect to x is going to be 10. That's just the multiplication. 2xy is going to give me 2y. Minus 3x squared is going to give me minus 6x. Minus 4y squared is going to be 0. Minus 18x is the derivative with respect to x is minus 18. Minus 28y, the derivative with respect to x is 0. And 12 is a constant. So there we go. The partial of h with respect to y is going to be, we're going to take the 10. It's just a multiplication. 2xy, the derivative with respect to y is 2x. Minus 3x squared, the derivative with respect to y is 0. Minus 4y squared, the derivative with respect to y is minus 8y. Minus 18x, the derivative with respect to y is 0. Plus 28y is going to give us plus 28, and the last term is 0. And so those are the partial derivatives that we're going to be using to solve the problem. Moving forward, we want to look at question A first. So question A is, where is the maximum? Okay, where is the maximum? In order to do that, I'm going to come here. A, we set the equation that del H should be equal to 0 at the maximum. That means that we have two equations. Del H over del X should be equal to 0, and del H over del Y should be equal to 0. Looking at these equations, obviously, when they're equal to 0, I can divide both sides by 20. The 10 comes out, and each one of these numbers is divisible by 2. So writing down the two equations, I'm going to put x first is going to be minus 3x plus y minus 9 should be equal to 0. That's the translation of the partial h partial x equal to 0. And then the partial h partial y is going to give x minus 4y plus 14 is equal to 0. So now I have a problem with two equations and two unknowns. There are many ways to solve it. One of my favorite is to multiply one of the equations by something such that you can add the equations and get rid of terms. So we're going to multiply this equation by 3, and then we're going to add the two equations. When we do that, this 3 is going, the plus 3 here is going to cancel with a minus 3 here. I'm going to get minus 12 plus 1 is going to give me minus 11y. I'm going to get minus 9 plus 42, which is going to give me a positive 33 is equal to 0. Solve that for y. That says that y is equal to 3. I can then take this y, I can plug it into this equation here. This is going to give me that x minus 12 plus 14 is equal to 0. Solve that for x. X is equal to minus 2. And so the answer we are going to have is 2 miles north, south, minus, and 3 miles east. So that is the answer for part A of where is the maximum. Moving on, looking at part B. Part B asks the question of, what is the value at the maximum? And so here, we know that the maximum occurs at, just a moment, let me add an extra sheet so as to not blot stuff. Okay. We know that the maximum occurs at x is equal to minus 2 and y is equal to 3. And so we just plug this in to h to find the height of the hill. And so h of minus 2, positive 3 is going to be equal to 10, 2 times negative 2 times 3 minus 3 times negative 2 squared minus 4 times 3 squared minus squared minus 18 times negative 2 plus 28 times 3 plus 12. We can simply grab a calculator and plug all of that in, and in the end we are going to find that h of minus 2 positive 3 is equal to 720 feet. The final problem is the question of what is the slope at the point minus 1i plus 1j. And there is the definition of the gradient. The magnitude of the gradient is going to give the slope. So we'll go ahead and calculate the gradient first. The gradient is this written right there. And so plugging that in, I'm going to find that dh over dx, at 1, 1 is going to be 10 times 2 minus 6 minus 18, which is going to give me 220. And I said 220 minus 220, and the units here are feet per mile. Ten, 2 minus 8 plus 28, which is going to be positive 220 feet per mile. The magnitude of del h is going to be the square root of the sum of the squares. So the square root of 220 squared plus 220 squared. And this is going to be 220 times the square root of 2, which is approximately 311 feet per mile. And the direction is going to be in the minus x, so in the southeast direction. And so this is in the southeast direction.